Okay, Pedro, this is the problem you asked about. I think I've got it right. I input the problem on Wolfram, which you can do right here. And then I just typed in solve, and I'll just show you what I did. Solve 1 divided by the absolute value of 3x minus 1 is less than 2 over x, and hit search, and it gave me this answer, and I said copy to the board. So there's our answer. And let's just review what it is we're trying to find. We're trying to find all the numbers on this number line, the real number line, that make this inequality true. And I don't see, I have a pretty advanced algebra and trig textbook here, and it doesn't have any problems in it like this. So solving a problem like this is rare. I'm not sure how the book that you have that had this problem in it shows you how to do these. But let me give you some ideas here. I think the first thing we want to focus on is where we could have some sign changes along the number line. And for sure, we can circle some numbers on the number line that x cannot equal. We know for sure that x cannot equal 0. Because if x is equal to 0, I'll be dividing 2 by 0, which is undefined. It's also the case that 3x minus 1, if that equals 0, we'll have a problem. And that happens when x equals 1/3. So 1/3. So the way I would think about it is that the number 0 and the number 1/3 can kind of divide the number line into 3 parts. To the left of 0, between 0 and 1/3, and to the right of 1/3. And what I'd like to do is see what kind of numbers I can get that solve this in each interval. For example, to the left of 0, when x is less than 0, what's true about 3x minus 1, the absolute value? Well, that will be positive. But this thing will be negative. So if I multiply both sides by x, when x is less than 0, I would end up with this. Notice I reversed the direction of the arrow, because when x is less than 0, I'm multiplying by a negative number. And when x is less than 0, guess what? This number is less than 0. It's negative. Whoops, I just meant to put a negative sign. And the denominator is positive because of the absolute value. So I'm going to get a negative number on the left, and that can never be greater than 2. So when x is less than 0, there's no numbers that will make this true. So I rule out anything to the left of 0. Now when x is between 0 and 1/3, this is almost like an art form for solving this. When x is between 0 and 1/3, what is is there a way to write this absolute value symbol without an absolute value symbol? when x is between 0 and 1/3, what is the value of 3x minus 1? Like if I put a 1/6 in here, 3 times 1/6 is 1/2. 1/2 minus 1 is negative 1/2. So I've got a negative number in here. So if I want to rewrite this without an absolute value symbol, bear with me. I have to rewrite it like this. In other words, when x is between 0 and 1/3, the expression inside the absolute value symbol is negative. So I have to take the opposite of that in order to write it without an absolute value symbol. And now, let's solve this inequality by cross-multiplying. Both of these expressions and the denominator are positive numbers when x is between 0 and 1/3. So I can just cross-multiply and say x is less than 2 times, well, I've got this minus sign from here, times 3x minus 1. So x is less than negative 6x plus 2. Add 6x to both sides. 7x is less than 2. Divide by 7. X is less than 2/7. So for the numbers between 0 and 1/3, the numbers that satisfy this inequality are the ones that are less than 2/7, which is, let's say, right here. That's these numbers right here. Okay, so that, what we did now, we just looked at the numbers in here, because that's where these expressions can change sign. And then I rewrote this without an absolute value symbol so I could solve the inequality. But I restricted this solution not just to numbers less than 2/7, but I'm in the interval from 0 to 1/3, so it's just these numbers right here. Now I'm going to look at the numbers of right of 1/3. So when x is greater than 1/3, how can I solve this inequality? It's like 3 separate problems. Well, when x is greater than 1/3, like a 2, the expression inside the absolute value symbol will be a positive number, so I can just drop the absolute value symbols. And when x is greater than 1/3, I can cross-multiply because both numbers are positive and keep the direction of the inequality the same. So I get x is less than 6x minus 2. So I've got, I'll do it this way, minus 5x is less than minus 2. Divide by negative 5, so I have to reverse the direction of the inequality symbol. X is greater than 2/5. So when x is greater than 1/3, the numbers in that interval that make this inequality true are the ones that are greater than 2/5, which is right here, about 0.4. So it's all these numbers. Or I can come down here, say 0.4. So that's what you have to do when you have a problem like this, is kind of think of dividing the number line into partitions, and then do what you need to do to solve the inequality for numbers in each partition. Okay. Now your book might have shown you a slightly different way to do it. I don't know. But the solution set is the union of two sets. Your book might have an answer like the interval from 0 to 2/7 union the interval from 0.4 to infinity. Those are the numbers that make this inequality true. Okay, and if you need additional clarification, we can talk about it next time we meet. I'll end the video here and post it on YouTube.